We put an incredible amount of trust in technology, right? From the autopilot flying our plane to the robots in a hospital. But what happens when these super complex systems just go wrong? Today, we're going to dig into this amazing report from the maritime world that shows the surprisingly simple reasons why some of the most advanced ships on the ocean can suddenly and completely lose control. Okay, so picture this. The year is 2006. We're on a massive pipelaying vessel way out at sea. This ship is being held in one perfect spot by a really sophisticated autopilot system. And deep inside the ship, an engineer and a service tech are just running some routine checks.
But this wasn't just any old test. As part of what they were doing, they decided to push one of the ship's powerful thrusters, the engines that keep it in place, to its absolute maximum. We're talking 100% full power.
But they missed one simple, absolutely crucial step. They were so focused on the mechanics of the test, they never picked up the radio to tell the operators on the bridge what they were about to do.
So what happened? Well, the ship's autopilot, totally in the dark about this test, suddenly felt this massive, unexpected force pushing the vessel. And before anyone on the bridge could figure out what was going on, this multi-thousand-ton ship was shoved 360 meters off its mark. That is nearly the length of 4 football fields. Just gone.
That 360-meter mistake, which is officially known as incident #0602, is the perfect way to kick off this whole explainer. It shows this hidden weakness in a technology that's all about precision and stability, a technology called dynamic positioning. So to really get what went wrong, we first have to understand the incredible technology that's supposed to make these kinds of mistakes basically impossible.
No, seriously, think about it for a second. You've got wind blowing, waves are crashing, currents are pulling. How in the world do you keep a giant industrial vessel just hovering over a single spot with pinpoint accuracy without ever dropping an anchor?
Well, the answer is dynamic positioning, or DP for short. It's basically a hyper-advanced autopilot that doesn't just steer the ship. It holds it perfectly still by constantly fighting against all the forces of nature.
So how does it pull this off? It's a constant 4-step loop. First, the system senses its position with a whole bunch of instruments. Then, its computer brain thinks, calculating all the environmental forces pushing it around. Finally, it acts, telling the thrusters exactly how hard to push and which way to push to fight back. And then it does it all over again and again, making thousands of tiny adjustments every single second. It's kind of like a person trying to balance on a giant wobbly yoga ball, just constantly adjusting to stay upright.
Okay, so if this technology is so smart, then what on earth happened back in 2006? Was that 360-meter drift just a one-off fluke, or was it a sign of a much bigger pattern? Well, let's take a look at the data. So our main source for this is a 2006 incident report from the International Marine Contractors Association. They looked at 36 major station-keeping failures to figure out, what's really going on here.
Now, if I were to ask you to guess, what would you say is the main culprit? Your mind probably goes to big dramatic stuff, right? Like massive thruster failures, or maybe catastrophic computer bugs. Let's see what the numbers actually say.
And this chart, this reveals the really surprising truth. Yeah, some of the smaller causes are what you'd expect, environmental stuff, power generation problems, computer and thruster issues. But look at the top 2. A full quarter of all failures were caused by reference systems. That's the sensors that tell the ship where it is. And right on its heels, at 22%, is human error. It wasn't the ship's muscle, it was its senses and its operators that were the biggest weak spots. So let's dig into these top 3 causes: reference systems, human error, and power generation. Because the specific examples in the report are just absolutely wild.
Just look at that. These top 3 causes add up to nearly 2/3 of all the incidents. So let's start with number 1, because it's a doozy.
So what does a reference system failure even look like? Check this out. In one incident, a vessel suddenly lost all of its GPS signals. Just gone. Why? The report says a massive solar flare erupted from the sun, and it sent this huge storm through the atmosphere that basically blinded the GPS satellites over that part of the planet. The ship's eyes were suddenly shut, not because of a glitch on board, but because of an event happening millions of miles away in space. All right, now let's talk about human error. And I want you to notice the pattern on this slide. When you look at that column for secondary cause, a theme just jumps right out: poor procedures. This tells you these aren't just random mistakes. It's a systemic problem where the process itself is setting people up to fail. And remember our story from the beginning? That was incident number 0602, human error caused by poor procedure.
This timeline shows just how ridiculously simple these failures can be. So, in this incident, a surveyor decides to change a GPS antenna. Simple enough. But they don't tell the DP operator on the bridge. So, boom, the system's main reference signal just vanishes. The computer, thinking the ship has somehow instantly teleported, fires the thrusters and sets off a bunch of alarms. All that chaos from a simple lack of communication.
So, after looking at all this data, what's the big takeaway? What's the real lesson here? Well, it's not that the technology is bad. It's something much, much deeper about how we work with it. We expect these big, spectacular failures, right? Thrusters breaking, computers crashing in a blaze of glory. But the 2006 data shows us a totally different reality. The real culprits are quieter, almost boring things. A sensor getting bad data from a solar flare, a little power supply glitch, and maybe most important of all, one person just not talking to another.
So here's the bottom line. We build this incredibly tough, resilient hardware, but a lot of the time, the real weak points are the simple connections. The connection between a sensor and a computer, or the connection between two teams on the same ship. The system isn't just the machine. The system is the machine and the people, and you have to design for both.
Which kind of leaves us with one last question to think about. As our technology gets more and more complex, are we actually focusing on the right problems? Or is the most unpredictable, failure-prone part of any advanced system, well, is it the human who's running it,